All right, on to the atomic number. As we just discussed, protons have a positive charge, electrons have a negative charge, and neutrons are neutral. So for right now, we're going to be talking about charges, we're going to ignore the neutrons. We'll talk about the protons and the electrons. So here's the deal. Protons are positively charged, electrons are negatively charged. Atoms, however, are neutral. They have no charge. How does that happen? Well, it turns out that for an atom to be neutral, it has to have the same number of protons as electrons so that the charges cancel out. So if you know how many protons an atom has, you know how many electrons an atom has. We don't know the number of neutrons. We'll talk about that later. So we have this thing called the atomic number. The definition of the atomic number, and this is hugely important here, the definition of the atomic number is the number of protons. Okay? Now, because an atom is neutral, the number of electrons will also be the same as the atomic number. However, the actual definition of the atomic number is the number of protons. And next unit we'll talk about that, why that's important. But one more time, the atomic number is the number of protons. Also, all atoms of the same element will have the same atomic number. So, for example, every carbon atom in the world will have the same atomic number, which means it'll have the same number of protons. Every carbon you run into will have the same number of protons. Okay? So the atomic number can be found on the periodic table. And so if we go back and start with our key, remember, again, every periodic table is set up a little differently, so we need to find the atomic number, and it says it's the top number. So we'll go back to our friend beryllium. So the atomic number for beryllium is 4. So every single beryllium atom you ever see will have 4 protons. Okay? Every single chromium will have 24 protons because its atomic number is 24. And every single sodium atom will have 11 protons because it has an atomic number of 11. So now, let me ask you this. If you run into a sodium atom, you know it has 11 protons. What else do you know? If it's a sodium atom and it has 11 protons, it also has 11 electrons. Okay. The atomic number can also be written with the element symbol. Okay, so what you have here is you have the element symbol, and this guy right here is carbon, and written down below it and to the right, to the left, it's too bad I don't know my right and left, so below and to the left is the number 6. And if we go back and look, it's not on there, never mind. The atomic number for carbon is 6. All right, we're now going to talk about mass number. Mass number, or the atomic mass, the definition is the number of protons plus the number of neutrons. Now, if you remember, we talked about a few minutes ago that when we're talking about looking at the periodic table, we can find the average atomic mass, and that number is written on the periodic table. And it's also, if we go back and look, let's find one. You can look at the atomic mass of, for example, iron, which is 55.85. Okay, but that's the average atomic mass. They took a whole bunch of iron atoms, put them together, weighed them, counted how many they weighed, and divided by that number, and they came up with 55.85. Okay, but when we're talking about the atomic mass of a single atom, just one atom, it's going to be the number of protons plus the number of neutrons. The reason that works, if you remember, a proton weighs 1 AMU, and the neutron weighs 1 AMU. Okay, so if you have an atom that has 1 proton and 1 neutron, its mass is going to be 2 AMU. Okay, so again, we're talking about an individual atom. We will talk about tomorrow why average atomic mass may be different. Okay, when we're talking about mass number of a single atom, you cannot have a fraction. You cannot have a decimal. You can't have half a proton or half a neutron. It just doesn't work. Okay, so the formula is written here. Atomic mass equals the number of protons plus the number of neutrons. So now, if you know the mass number and the number of protons, you can figure out the number of neutrons. And we'll do that in a minute. Okay. The mass number, or the atomic mass, can also be found on the periodic table. Remember, however, that it's an average. So what you're going to do is round, because you can't have a fraction. So when we're doing some mathematical calculations that I'm going to show you in a minute, you need to round to the nearest whole number, okay? Round to the nearest whole number. Okay, so the atomic mass can also be written with the element symbol. So we have carbon here. Its atomic number is 6, and its mass number is 12. And remember, mass number means it's also the number of, no, not mass number, sorry. Atomic number is the number of protons and also the number of electrons. All right, so now let's try some practice problems. We'll start with nitrogen. So let's go to the periodic table and see what we can find out about nitrogen. So nitrogen is located here. We know it has, and we look at this 7. It has an atomic number of 7, and it has a mass number of 14.01, which we're going to round to the nearest whole number, which would make it 14. All right, so let's go fill that in our table. We said it's had atomic number of 7 and an atomic mass of 14. All right, so from that information, we need to figure out the number of protons, neutrons, and electrons. So, how do we figure out the number of protons? Well, the number of protons is the same as the atomic number. How do we figure out the number of electrons? That's the same as the number of protons. And now, how do we figure out the number of neutrons? We just learned a formula. Mass equals number of protons plus number of neutrons. We know the mass is 14. We know the number of protons is 7. So now we just need to figure out the number of neutrons. So to solve this problem, we're going to subtract both sides by 7. And that gives us the number of neutrons, which is 7. Okay, let's try another one. Why don't you hit pause, try to do this without me, and then hit play and see how you did. All right, so sodium has, sodium's over here, it's an Na, a little confusing. It has an atomic number of 11 and a mass of 22.99, which we're going to round to 23. Okay, so let's fill that information in. We have an atomic number of 11 and a mass of 23. So from there, being that we know the atomic number, if you remember, the atomic number is the number of protons. So that is going to be 11. And the number of protons also equals the number of electrons. So that will also be 11. And the number of neutrons is the atomic mass equals the number of protons plus the number of neutrons. We'll subtract 11 on both sides, which gives us 12. Okay. One more. Again, hit pause, see if you can do it on your own. All right. So now we have carbon 13. Let's find carbon 13. Carbon has an atomic number of 6 and a mass of 12. Okay, but we got to think about this one for a minute. Let's go back to the other slide. Our atomic number is 6. We had a mass of 12, but we have here carbon 13. Whenever you have a number written like that, that is this particular carbon's mass. Remember, this number here is an average. That 13 is for that particular carbon. Okay, so in this particular carbon, the atomic mass is 13. All right, atomic number is 6, which means we have 6 protons and 6 electrons. To figure out the number of neutrons, we will take the atomic mass, which equals the number of protons, plus the number of neutrons. We'll subtract 6 from both sides, and that gives us a 7. All right, there you go. That's it for today.